line AB is perpendicular to HP and parallel to VP, where the point A is H units above HP and point B is D units in front of VP. Observe the front view of line AB as line A-B'. As you can see from top, point B is visible and it hides point A. So, projectors from point B passing through A meets HP at point BA, which is the top view. So, let's see how it will appear on paper. For this, first draw a horizontal reference line XY. Then draw a line A', B' above and perpendicular to XY with endpoint A' at a distance of H units from XY. Next, mark a point BA below XY at a distance of D units in line with line A', B'. Line A', B' and point BA are the projections of the line AB on VP and HP respectively.
Line inclined to one plane and parallel to the other. The inclination of a line to a plane is the angle which the line makes with its projection on that plane. Line PQ1 is inclined at an angle theta to the HP and is parallel to the VP. The inclination is shown by the angle theta which PQ1 makes with its own projection on the HP, that is the top view PQ1. The projections may be drawn by first assuming the line to be parallel to both the HP and the VP. Its front view P', Q' and the top view PQ will both be parallel to XY and equal to the true length. When the line is turned about the end P to the position PQ1 so that it makes the angle theta with the HP while remaining parallel to the VP, in the front view, the point Q' will move along an arc drawn with P' as center and P', Q' as the radius to a point Q'1 so that P', Q'1 makes an angle theta with XY. In the top view, Q will move towards P along PQ to a point Q1 on the projector through Q'1. P', Q'1 and PQ1 are the front view and the top view respectively of the line PQ1. Line RS1 is inclined at an angle phi to the VP and it's parallel to the HP. The inclination is shown by the angle phi which RS1 makes with its projection on the VP, that is the front view R'(H'1). Assuming the line to be parallel to both the HP and the VP, its projections R', H' and RS are drawn parallel to XY and equal to its true length. When the line is turned about its end R to the position RS1 so that it makes the angle phi with the VP while remaining parallel to the HP, in the top view the point S will move along an arc drawn with R as center and RS as radius to a point S1 so that RS1 makes the angle phi with XY. In the front view, the point S' will move towards R' along the line R', S' to a point S'1 on the projector through S1. RS1 and R-S-1 are the projections of the line RS1. Therefore, when the line is inclined to the HP and parallel to the VP, its top view is shorter than its true length, but parallel to XY. Its front view is equal to the true length and is inclined to XY at its true inclination with the HP. And when the line is inclined to the VP and parallel to the HP, its front view is shorter than its true length, but parallel to XY. Its top view is equal to its true length and is inclined to XY at its true inclination with the VP. Hence, when a line is inclined to one plane and parallel to the other, its projection on the plane to which it is inclined is a line shorter than its true length, but parallel to the reference line. Its projection on the plane to which it is parallel is a line equal to its true length and inclined to the reference line at its true inclination. In other words, the inclination of a line with the HP is seen in the front view and that with the VP is seen in the top view.
Let's move further discussing a case where the line AB is inclined to both HP and VP and its projection will be shorter in length compared to its actual length. Look at the diagram. Here, line AB is assumed to be parallel to VP but inclined to HP by the angle 45 degrees. Observe its front view
A-B-1
on VP gives the true length and the inclination with XY. The top view is a shorter line AB1 parallel to XY. Now the opposite case. The line AB is assumed to be parallel to HP and inclined to VP by the angle 30 degrees. Observe line AB2 is the top view making an angle 30 degrees with VP. Since the line is now assumed to be parallel to HP, its front view is a line
A-B-2
parallel to XY. At last, to rotate the line
A-B-2
to the final position, draw the locus of the endpoint B in front and top views. Locus of the point B' is a line passing through
B-1
and parallel to XY. With A' as center and
A-B-2
as radius, draw an arc cutting the locus line of
B-1
at B'. The line A', B' is the required front view of the given line. Now, similarly, with A as center and AB1, draw an arc cutting the locus line B2 at B. The line AB will be the top view of the given line. Well, this completes the discussion about the projections of the straight line.
Projection of a point on an auxiliary plane. 1. Projection of a point on an auxiliary vertical plane. A point A is situated in front of the VP and above the HP. AVP is the auxiliary vertical plane inclined at an angle alpha to the VP. The HP and the AVP meet at right angles in the line X1, Y1. A' and A are respectively the front view and the top view of the point A. A'1 is the auxiliary front view obtained by drawing a projection A'1 perpendicular to the AVP. it can be clearly seen that A-1, O1, the distance of the auxiliary front view A-1 from x1, y1 is equal to A-O. The distance of the front view A' from xy is equal to AA, the distance of the point A from the HP. The figure shows the VP and the AVP rotated about the HP to which they are perpendicular. The line of intersection x1, y1 between the AVP and the HP is inclined at the angles alpha to xy. The line joining the top view A with the auxiliary front view A-1 is at right angles to x1, y1 and intersects it at O1. Note that A-1, O1 is equal to A-O. To draw the orthographic views, start with the reference line xy and mark the front view A' and the top view A. Draw a new reference line x1, y1 making the angle alpha with xy. Through the top view A, draw a projector A'1 perpendicular to and intersecting x1, y1 at O1 and such that A'1, O1 is equal to A'(O). A'1 is the required auxiliary front view. The new reference line making the angle alpha with xy can be drawn in 4 different positions as shown in the figure by lines x1, y1, x2, y2, etc. All the front views are projected from the top view A and their distance from their respective reference lines are equal. That is, A'1, O1 is equal to A'2, O2, so on is equal to A'(O). Projection of a point on an auxiliary inclined plane. A point P is situated above the HP and in front of the VP. AIP is an auxiliary inclined plane making an angle beta with the HP. It meets the VP at right angles and in a line x1, y1. P' and P are respectively the front view and the top view of the point P. P1 is the auxiliary top view obtained by drawing the projector PP1 perpendicular to the AIP. It can be seen that P1, O1, the distance of the auxiliary top view P1 from x1, y1 is equal to PO, the distance of the top view P from xy is equal to PP', the distance of the point P from the VP. The HP and the AIP are then rotated about the VP to which they are perpendicular. X1, Y1, the line of intersection between the VP and the AIP makes the angle beta with XY. The line joining the front view P' and the auxiliary top view P1 is at right angles to X1, Y1 and intersects it at O1. Note that P1, O1 is equal to PO. To draw the orthographic views, draw XY and mark P' and P. Draw X1, Y1 making the angle beta with XY. Through the front view P', draw a projector P', perpendicular to and intersecting X1, Y1 at O1 and such that P1, O1 is equal to PO. P1 is the required auxiliary front view. In this case also, the new reference line can be drawn in 4 different positions as shown in the figure by lines x1, y1, x2, y2, etc., each inclined at beta to xy. All the top views are projected from the front view P dash and their distances from their respective reference lines are equal. That is, P1O1 is equal to P2O2, so on, equals PO. If the inclination of the AVP with the VP is increased so that alpha equals 90 degrees, the AVP will be perpendicular to both the planes. Similarly, if the inclination of the AIP with the HP is increased so that beta equals 90 degrees, it will also be perpendicular to both the HP and the VP. This plane is also called the profile plane PP. It may be rotated about any one of the two principal planes. The view on this plane can therefore be projected from either the top view or the front view and named accordingly. Projection of a point on an auxiliary plane perpendicular to both the principal planes. In the figure, A is a point, PP is an auxiliary plane perpendicular to the HP, and the VP A1 is the auxiliary view projected on the PP. It can be seen that A1O2 is equal to A-O is equal to AA, the distance of A from the HP. Also, A1O1 is equal to AO is equal to AA dash, the distance of A from the VP. The figure shows the PP rotated about the VP. A1 lies on the projector drawn through the front view A dash and perpendicular to the line of intersection between the VP and the PP. It is thus projected from the front view and hence called the auxiliary top view. In technical drawings, this view is generally termed as the side view, end view or end front view. Note that A1O1 is equal to AO. Note that when seen from the left, the new reference line and the side view are placed to the right of the front view. When seen from the right, they would be placed to the left of the front view. Thus, the view seen from any side of the front view is placed on its other side. The figure shows the PP rotated about the HP. The view on the PP now lies on the projector drawn through the top view A. Hence, it is called the auxiliary front view. In this case, A-1O2 is equal to A-O. The orthographic views in both these cases are self-explanatory. To determine true shape of a plane figure. Problem 11.8. Projections of a pentagon resting on the ground on one of its sides are given. Determine the true shape of the pentagon. AA is the true length of the side because it is parallel to the HP. Draw a reference line x1, y1 perpendicular to AE. Project an auxiliary front view on it. It will give a point view A-1 and E-1 of AE and an edge view A-1, C-1 of the pentagon. Draw another reference line x2, y2 parallel to A-1, C-1 and project an auxiliary top view A1, B1, C1, D1, E1, which will be the true shape of the pentagon. Projections of a plane. Problem 12.7. A rectangular plane surface of size L into W is positioned in the first quadrant and is inclined at an angle of 60 degrees with the HP and 30 degrees with the VP. Draw its projections. The plane is first assumed to be parallel to HP with its shorter edge perpendicular to the VP. In this position, true shape and size of the plane is given by its projection on HP. The front view will be a true line parallel to the reference line XY. Rotate the front view projection by 60 degrees, the angle of inclination of plane with HP. Draw vertical lines from the ends of line A-D- and B-C- to intersect horizontal lines drawn from the top view ABCD at points B1, C1, D1 and A1. Join A1, B1, C1, D1 to obtain the top view of the plane in this inclined position. Now rotate the edge D1C1 of the top view by 30 degrees, the angle of inclination of plane with VP, and reproduce it as shown. Draw projections from A1, B1, C1 and D1 to intersect the horizontal projections from A-D' and B'-C' to get the points A-1, B'1, C'1 and D'1. Join the lines A-1, B'1, C'1, D'1 to obtain the final front view of the given plane surface. Projections of solids. Types of solids. Solids may be divided into two main groups. 1. Polyhedra and 2. Solids of revolution. Polyhedra. A polyhedron is defined as a solid bound by planes called faces. When all the faces are equal and regular, the polyhedron is said to be regular. There are 7 regular polyhedra which may be defined as stated below. 1. Tetrahedron. It has 4 equal faces, each an equilateral triangle. 2. Cube or hexahedron. It has 6 faces, all equal squares. 3. Octahedron. It has 8 equal equilateral triangles as faces. 4. Dodecahedron. It has 12 equal and regular pentagons as faces. 5. Icosahedron. It has 20 faces, all equal equilateral triangles. 6. Prism. This is a polyhedron having 2 equal and similar faces called its ends or bases, parallel to each other and joined by other faces which are parallelograms. The imaginary line joining the centers of the bases is called the axis. A right regular prism has its axis perpendicular to the bases. All its faces are equal rectangles. 7. Pyramid. This is a polyhedron having a plane figure as a base and a number of triangular faces meeting at a point called the vertex or apex. The imaginary line joining the apex with the center of the base is its axis. A right regular pyramid has its axis perpendicular to the base, which is a regular plane figure. Its faces are all equal isosceles triangles. Oblique prisms and pyramids have their axes inclined to their bases. Prisms and pyramids are named according to the shape of their bases, as triangular, square, pentagonal, hexagonal, etc. Solids of revolution. Cylinder. A right circular cylinder is a solid generated by the revolution of a rectangle about one of its sides, which remains fixed. It has two equal circular bases. The line joining the centers of the bases is the axis. It is perpendicular to the bases. Cone. A right circular cone is a solid generated by the revolution of a right angled triangle about one of its perpendicular sides, which is fixed. It has one circular base. Its axis joins the apex with the center of the base to which it is perpendicular. Straight lines drawn from the apex to the circumference of the base circle are all equal and are called generators of the cone. The length of the generator is the slant height of the cone. Sphere. A sphere is a solid generated by the revolution of a semicircle about its diameter as the axis. The midpoint of the diameter is the center of the sphere. All points on the surface of the sphere are equidistant from its center. Oblique cylinders and cones have their axes inclined to their bases. Frustum. When a pyramid or a cone is cut by a plane parallel to its base, thus removing the top portion, the remaining portion is called its frustum. Truncated. When a solid is cut by a plane inclined to the base, it is said to be truncated.
Hi friends, now we shall discuss projections of solids with a special case, that is axis inclined to one of the reference planes and parallel to the other. To solve such problems, alteration of position method is used. In that, initially the axis of the solid is assumed to be perpendicular to one of the planes. Then, view showing its true shape and size is drawn. Next, other views are constructed by projecting the details from the first view. And finally, position of one of the views is altered as per requirements and remaining views are generated once again. To understand this method, let's solve a problem. A pentagonal prism has base side length of 25 mm and axis length of 50 mm. It is resting on one of its rectangular faces on HP. The axis is inclined at 45 degrees to the VP. Now to draw the orthogonal views in this position, we shall assume that its axis is perpendicular to VP. Observe that the true shape and size of the pentagonal prism is seen in the front view. We shall generate pentagon in the front view with base parallel to XY. Then let's construct the top view by projecting the details from the front view. Now we will follow the procedure to alter the position of the top view. First, let's draw the axis line at 45 degrees to XY and adjacent to the existing top view. the axis length is 50 mm. Then draw a perpendicular line x1 y1 passing through this axis. Next, we shall draw a line x2 y2 parallel to x1 y1 at a distance of 50 mm. Use a divider to measure the distances of the corner points from the existing top view and mark them respectively in this new inclined top view. Finally, connect all points in proper sequence. Here observe that the hidden lines are shown in dotted pattern. Then project all points from this top view above line XY. These projectors will intersect the horizontal projectors drawn from the existing front view. Mark the intersecting points and complete front view in this altered position. Observe the hidden lines are shown as dashed lines coincide with other visible lines. And here we have a complete solution of all the views. So friends, these are basic steps in constructing the views when axis of the solid is inclined to one of the reference planes.